Welcome to this session. I think to start off, I want to introduce myself and the panelists. I'm Anna Rose. I'm the host of ZeroKnowledge podcast. If you don't know it, check it out. I run events like the ZK Summit and the ZK Sessions, and I also have a ZK validator running on Mina. I'm here with Justin Drake, who's a researcher at the Ethereum Foundation working on ETH2, and Izaak Meckler, who's a co-founder of O1 Labs and a co-creator of the Mina protocol. Cool. So this is the panel all about the state of zero-knowledge proofs. ZK is very well known for privacy and scalability through the L2 ZK rollups. But what we wanted to start this off with was a conversation about new use cases, kind of like new ideas that are floating around how you can use zero-knowledge proofs. So Izaak, I know you have a bunch of ideas in this direction. Why don't you start off?
Oh yeah. All right. We're right in the thick of it.
Right in it.
So yes. So I was telling my lovely co-panelists beforehand. Okay, I'll try to make this quick because it's kind of, I don't want to drone on, but it's funny almost. I realize it's kind of funny to ask about ZK use cases because people, it's a bit like, it's actually exactly like asking about like what are use cases for programs or like what are use cases for computers. More like what are use cases for programs, I guess, because a zero knowledge proof system is just parameterized by a program, or maybe even more data than a program. Yeah. So it's a very, very flexible technology, and which means that basically the actual, taking one step back, why do we even ask about use cases? Why are we even curious about that? I think, maybe I'm wrong, it's because we wonder, how is this going to impact our world, right? How is this technology going to impact our world? And that question depends a lot for a given technology on how flexible that technology is. Mm-hmm. So the more flexible the technology is, the more the impact will be determined or affected by the configuration of powers and social forces which are capable of acting on that technology. You know what I mean? So you have some technologies which are very specific, like a bomb.
Yes.
And it's like, what's a bomb going to do? It's going to blow something up, right? But you have other technologies that are very flexible, and so their application depends a lot on the configuration of powers. But that's all just to say, I will propose. We know a lot about the applications of these technologies that are supportive of things like financialization of everything under the sun, or asset, whatever, speculation or whatever. We know all about these use cases. So I'll try and mention some use cases which have nothing to do with our usual configuration of powers that we know about. Maybe it's more interesting. Here's one that I thought of. It's sort of a category use cases, which is sort of flexible modes of authentication. So if you have some record somewhere that has some information, some private record that has some information about you, and some object in the world. So let's say, okay, this is a really stupid example that I also mentioned before. It's really stupid. So please, everyone watching, don't think this is a real example. You should use it as a template example. Mm-hmm. Think about a vending machine that's on your corner. And some nice person lovingly set up this vending machine for all their neighbors to enjoy sodas and seltzers and bottled tea and so on. But they only want it for their neighbors. So if you go up to this vending machine, you need to provide a proof that says, I'm really, my address is in this neighborhood. So there's an application of zero-knowledge proofs, which is flexible modes of authentication, proving something about some property holds about, something. That's one application. Another one, and then I'll shut up. Maybe two more. So
take your time.
Kind of like durable forms of reputation. So right now, like, say, for example, vendors on online marketplaces have reputations. I did this many sales for these objects and so on. This is my rating. But it's very specific to the platform. So like Amazon has its ranking system, eBay, they have their ranking system, dark web websites, they have their own ranking system and so on. There's no durable form of reputation which is transferable between systems. And with zero-knowledge proofs, you could do this in a way that would respect the privacy of the buyers who transacted with those senders. So like
nice.
the vendor could sort of have like a private record of all the sales that it made, and then it could use a ZKP to like prove my rating across all platforms like is this or whatever. And then, okay, one more. That one does have to
Sounds
do with
good.
the current existing configuration of powers, I guess. Okay, the final thing is, okay, so imagine you are, oh, I don't know, let's make it topical. So imagine you're like an Amazon worker in Georgia or something, and you're like, wow, I really don't like my life or my work. I want to join the union. But you need to have a way to coordinate with your fellow workers without fear of retaliation from the boss or whatever. So perhaps there would be some way to commit. I'm going to vote yes for the union, and that would enable you to join some union supporters only chat or something like that. And so you could use this like flexible authentication to be able to do that. Say, I'm allowed in because I already committed to voting yes or something like that.
This is ZK for creating unions. This is
yeah. So there's
I've not heard that.
There's some
definitely a new one.
There's some ideas. Okay.
Hey, Justin, do you have any ideas to add to that? Maybe even something that's already kind of being explored.
Yeah, so I guess beyond scalability and privacy, I think another interesting blockchain use case is interoperability between consensuses and VMs. Because if you take, for example, the Mina blockchain, that produces zero-knowledge proofs which are not easily consumed by the Ethereum blockchain and the EVM. And so, it turns out that one use case of SNARKs is to basically be an interoperability layer, just one extra wrapper SNARK that will basically make it consumable by one VM to another. I guess on the VM point, I guess there's another use case, which is experimentation. So, right, we have this Polkadot vision, which is kind of interesting, where you can spin up your parachains, and each parachain has a new VM, and that's great for experimentation of VMs. And it turns out you can do the same thing with SNARKs, in the context, for example, of the EVM. So, you have teams like Starkware or zk-SNARK or many other teams that are defining their own new VMs, and they're basically only putting on the Ethereum blockchain the verifier circuit or the verifier keys, and that's sufficient to kind of open up this little universe with new rules and logic.
It's almost like ZK rollups plus, eh?
Yes. So not only do you get the scalability of rollups, but you also get the freedom to experiment and innovate at the VM layer. Exactly. And then, to Isaac's point, he was saying that SNARKs are so general because they deal with programs. And I totally agree with that. And when you look at cryptography, many parts of cryptography deal with programs natively. So for example, MPCs, multi-party computation is on programs. And then you have things like fully homomorphic encryption. That's also programs, and witness encryption or indistinguishability obfuscating. All of this is dealing with programs. And so what we're doing is we're building tools and techniques to work with programs. So for example, we have hash functions, which are very friendly to arithmetization. We have all sorts of tools with dealing with programs. And another interesting thing is that SNARKs can unlock other cryptographic primitives. So for example, when you do MPCs, you have multiple parties and you want them to behave honestly. And one way to enforce this honest behavior is just to have them prove that they've done valid computation. And so you can use SNARKs as a building block for MPCs, which is very cool.
Which is so funny because we always hear kind of MPCs more as like a building block to zk-SNARKs, and here it's the opposite. That's so cool.
Yeah, here's the opposite, yeah.
Oh, and let me just add on to what Justin was saying, to his first point about the wrapper SNARK verifying the Mina blockchain or Mina SNARK on EVM. If anyone is so inclined and you still have some time to submit a proposal, I'll just do a little plug. We have an RFP, a request for proposals currently for building like this wrapper SNARK to have the Mina blockchain verified on EVM. So check it out. I'm not sure what the best way to actually submit something. Maybe go to Justin's Twitter. I don't know. He tweeted about it. I don't know. I can put the link.
I want to bring up one last use case before we move on that actually, Izaak, I think you mentioned over a year ago on the podcast, it was something about the idea that sometimes you have like closed source software, but you actually want to prove that something has been included or not without revealing what's inside there. And I always thought that was a very compelling case, but I haven't yet seen anyone do it. Have either of you seen that, or have you developed that idea at all? Still not?
No, actually not yet. I think, to answer the question of why hasn't anyone done it, I guess probably requires looking at the balance of powers and incentives and so on. It's a really regulatory kind of use case. So, the whole activity of the space is mostly driven by profit seeking so far, right? So I don't think there's it's not obvious to me what the profit model would be. So
it might be more a response to regulation, though. That's interesting. I'm thinking we can now move on. We wanted to talk a little bit about the layers of the ZK stack. So this is like the zero knowledge space has really been very, very active over the last 3 years, I would say. And over the last year and a half, we've actually seen a lot of applications and implementations come forward. And through that, there's sort of the settling of this ZK tech stack. And so Justin, maybe you can help walk us through what is the ZK tech stack exactly?
Yeah, so I mean, one of the big kind of realizations of last year, I guess, was that there's when in your SNARKs stack, you have at least two components. At the very bottom layer, you're working with these polynomial commitments. So you're working with polynomials, which are very low-level mathematical objects, and polynomial commitments. So there's lots of examples of polynomial commitments. For example, there's cat-tape, there's fry, there's dark, etc., etc. And each of these polynomial commitments will have a different set of cryptographic assumptions attached and a different kind of performance trade-offs associated. And then you have another layer, which is this IOP layer, which is once you have a program, how do you arithmetize it? And then how do you incorporate the polynomial commitments? And kind of you have these interactions between provers and verifiers. I guess the way that people used to build SNARKs, design SNARKs, is they would design the whole thing. But because we've been able to modularize, we've been able to simplify greatly. And we now have the power also to swap out components and try out new ones. So if you have n polynomial commitment schemes and m IOPs, you can kind of have n times m different schemes. And then kind of one of the cool developments of this year, I guess, is kind of this third layer, which I guess you could think of as a technique, which is the Halo recursion technique. When Halo was first presented, it was kind of bundled, right, with everything, with the IOP, with the PCS. And one of the realizations is that this technique really works in very large generality. And so we're going to see, Halo techniques being used across the whole industry and across all SNARKs. And recursion has, lots of advantages, which I guess we could talk about.
Cool. And I know, Izaak, in our pre-discussion, you had a slightly different vision of this tech stack.
Oh yeah, I just wanted to maybe complicate the third thing a little bit, just because you said okay, from the first, right? So if you have n options for polynomial commitment scheme and m for IOP, then you have n times m choices for the first two. But the third one, I mean, you need to specify. I mean, we need to, I guess, try and figure out a precise way of talking about it, because maybe the choice is the branching factor. That's maybe what you mentioned before, how many proofs verifiers are inside of a circuit. That's maybe one choice. But the specific accumulation technique is kind of determined by the choice of polynomial commitment scheme and IOP. So,
right. I mean, one kind of subtlety which you can configure is: do you want what's called incrementally verifiable computation, or do you want what's called proof carrying data? So the subtlety here is: do you have a single prover who's kind of incrementally doing the computation and kind of having a SNARK come with every step of computation? Or do you have a scenario where you have multiple untrusted provers all kind of working together to move the things forward. And it turns out that this second flavor, the proof carrying data, is really, really powerful. Like one of the things that it unlocks is the idea of distributed proving. Another thing that it unlocks is liveness in the context of blockchains. So if you have a single prover in the IVC context, you don't have to trust that prover for correctness. As in, if you have a SNARK, the corresponding statement will be true, but you do have to trust him for liveness in the sense that if he goes offline, you no longer have this nice stream of proofs coming out. Yeah. And I guess go ahead.
Oh yeah. Like for in Mina, it is kind of a fully we really use the full power of PC like proof carrying data. Like there is a whole big scheme with lots of different provers and so on. But I guess what I mean to say is incrementally verifiable computation is like a special case of proof carrying data, right? And like proof carrying data as you would write like a program that's we have a library called Pickles that like implements proof carrying data. It's sort of parameterized over a polynomial commitment scheme and an IOP, as so long as those two things are also equipped with an accumulation scheme. And then given a set of circuits that you want to do PCD for, it'll spit out, a system for doing PCD. So I just meant to say like this kind of third thing of like accumulation scheme is more constraint on the kind of inputs that you can, on the pairs, like which n times m pairs can you actually use to fuel a PCD scheme than it is an additional choice. And then there is the set of circuits that
there's almost categories through those three layers. Is that kind of what you're saying? Like the choice you make at that first layer could actually determine which third layer you're going to have to use?
Yeah, basically.
Or could use?
Yeah, exactly. I'm saying like, okay, you want to like build a SNARK, you want to build a PCD system. That's what you want to do. Okay, what do you got to do? You have to choose the circuits that are involved in the PCD. You have to choose and then you have to choose the polynomial commitment scheme and the IOP, subject to the constraint that those two things together have some kind of accumulation scheme. And the choice of that accumulation scheme is dependent. How many choices you have for that accumulation scheme could be 0, could be 1, could be 10, is dependent on which IOP and polynomial commitment scheme you chose. That's all I wanted to say.
Got it. Like actually continuing on this topic though, like not only are these, we've just mentioned the three layers, and within those three layers, there's different options. There's also like new languages coming out around, like to write ZK circuits, to write sort of anything built on top of it. So I was hoping we could have a quick conversation about the languages in the ZK world, because there's a lot. And it sort of feels like every project is now releasing a language. And I wonder, does that mean that it's going to be easy to onboard new people, or is every single project going to be kind of like teaching people their particular language?
I can comment on it just from the main experience that we have with this was from a workshop that we did in London. It was great actually. It was me and Matthew, who's awesome and works on Mina, it was Socrates also. The whole Socrates team was there. So like we did Snarky, they did Socrates. There's definitely a lot of common. All the languages are kind of the same. I mean, let me just say it like that. So there's definitely like a lot of common learning that people can share across it. But I would say my main like unhappiness with the current state of affairs is like everyone is speculatively building out their own set of tools, their own package manager, their own IDE, their own whatever. It seems very silly to me. I don't, like the problem that we're solving is not that different from the normal problem of building software. The set of programs, that you can describe is a bit different, but the concerns about packaging and all that is similar. So I wish everyone would come together
and pick one. But so I did an episode all about ZK languages recently. And what I learned through that was like, there are languages focused in on different layers, and there are languages that will have a very narrow focus and others that are very, very generalized. And could it be that the reason that we're seeing so many new languages right now is just that it had like no standard has been determined and there is no clear winner? There are some that have had more adoption, like Circom is very, very much adopted, but like, does that mean that becomes the standard, or are we sort of waiting?
I think that's part of the reason is because like, everyone has their own snark. It's all, they're all slightly different, blah, blah, blah. I think that's part of the reason, but I think the real reason is driven by the economics, which is that you have all these like startups, right? Who I'm sure, are trying to be like the winner take all like snark tool manufacturer or whatever. So that's the real reason, right? I mean, that's why Starkware has a language. That's why whoever, I don't know who else, but right. I mean, let's be honest.
But you also have a language, do you not? There's Snarky. Where do you place that?
Yeah, so Snarky is kind of like an embedded DSL in OCaml. It is kind of a language, but it's something that we developed primarily for us to use in developing Mina. As we're developing the kind of external developer, SDK for snaps, the most likely route that we will pursue is not making our own language. It's not entirely, it's still a little bit up in the air, so I won't maybe comment further than that, but maybe let me leave it at that.
Justin, did you have any thoughts on this? Languages?
I mean, the language layer is not really my specialty, but I agree from a user perspective, it's not ideal, right? Because there's no standards, there's like 5 to 10 different options to choose from. The tools are very, very basic, but at the same time, I think we're at this very early stage where experimentation and competition, I think, is or can be pretty healthy. And there are some real technical differences sometimes. So, for example, are you compiling down to a circuit, or are you compiling down to an execution trace? Do you have access to recursion? Do you not have access to recursion? Is your finite field a large one, a small one, or a binary field or whatever? That all of these things will have consequences, I guess. Yeah.
I agree with those are all really good points.
So kind of like the second to last topic that we wanted to cover in this talk was actually to touch on the topic of hardware when it comes to ZK computation. So I remember there's been talk of this for a while, but I am curious to hear kind of what's the status of hardware and ZK right now? What do we see? Are there actually, I mean, I did interview one team that is, doing some of this stuff, but are there a lot of people entering the space? Is there going to be specialized hardware for zero-knowledge computation? Does it already exist to some level?
Right. So there have been some teams that have tried to do acceleration using GPUs and FPGAs. I guess we're in the sad state of things right now, at least in the context of the EVM, where the majority of the cost, for example, in a rollup, is just putting data on the blockchain because the fees are so high. And so the cost of doing the proving is minimal compared to the cost of putting the data on chain. So there's, I guess, little financial incentive. You can just get huge, data centers on AWS to do the proving. And that's an advantage of SNARKs, is that they're very parallelizable. I guess the downside here is that you're losing on decentralization. It would be nice if we had systems where anyone from home could prove these SNARKs. And that's one of the goals that we have for the Ethereum Foundation. One of the holy grails is to have a ZK VM, right? So an equivalent of the EVM that is Turing complete, and at every single block you have a corresponding proof. And really, to get there, I think we're going to need ASIC acceleration if we want both the scale and the prover power, but also the decentralization. And so, we have a multi-million-dollar project that we're about to announce, soon. But I can't give more details.
Somewhere around hardware and ZK. Ooh, that's good.
Exactly. Yes.
We'll keep our eyes out for that.
So it's coming, and it's very exciting. Yeah.
Nice. I mean, the thing is, in your case, what you described is the computation can kind of be somewhat inefficient because the cost to write on chain is so high. But in other blockchain cases, that isn't so. And I feel like maybe you have some thoughts on that, Izaak, and hardware and how important that is.
Yeah. Would I put this? Okay. Well, yeah. I mean, I think the cost of writing on chain, yeah, there will always be some substantial costs associated with that. But let me just return to the point of hardware in general. There is kind of this inherent overhead to making a computation verifiable, right? Of snarkifying a computation, which is kind of a shame, especially, if you think that some large, I think probably, depending on the energy costs and so on, it probably makes sense for a large subset of the world's computations to be verifiable, for the programs that people are interacting with to have to prove themselves, in some way to the user. And so it's a shame that from an energy usage point of view that there is a huge overhead. So I think that's something that's very exciting to me about these hardware systems, because it could make it possible for, more and more computations to be verifiable at the same level of energy usage. And I suppose the same financial cost, but who cares about that?
Yeah. I mean, go ahead.
No, I was just going to say, it's an exciting time for SNARKs right now, in the sense that a lot of the research has been done, like the cryptographic research has been done. And so the problem with cryptographers is that there's only so many in the world, and you need to be really smart, and it takes a long time to become a leading edge cryptographer. But on the other hand, there's a lot of engineers, performance engineers and tooling engineers. And now that we've done the research for SNARKs, there's a huge opportunity for all these to open the floodgates and bring in lots of new talent that will basically take the existing constructions and make them production grade in terms of performance and security and tooling and all these things.
And speaking of new talent, this brings us to our last point that we all wanted to talk about, which is there is a relatively small group of people in the world who really know how to design these systems and to build them, to implement this. And I think all three of us actually have a desire to see way more people join the space, but there are barriers to that. ZK is not simple to get right away. I think the engineering, at least for the last few years, has been very complex, very complicated. You need a certain level. But do we feel have things become more settled? Are there now tools where more people could get involved? Or medium? We're kind of in the middle still?
I would say yes and no. Oh, sorry, go ahead, Justin.
No, go ahead.
I was just going to say yes and no. I think, as Justin was kind of alluding to earlier, there's now a lot clearer picture of how of all the various components of these systems and how they can sort of be fit together. And also just, because it used to be there's Groth 16. It's like some perfect crystal that Jens Groth pulled out of the air or whatever. And so now that's not the case, and there's these objects are now more scrutable to mere mortals like me and everyone else. So and also just with time, there's just been we've had all these conferences, we've had all this education and so on, and so there's more companies, so there's just more people, and I mean there's not one. What kind of sucks is that everyone has their own implementation of some whatever, the same Rust trait that's the curve with the finite field and the thing, and the constraint system and whatever. So, but at the same time, there's sort of a common understanding, and people, everyone has their own Planck, everyone has their own blah blah blah. So things have improved, but not maybe at the level of conceptual understanding, not at the level of implementations yet.
Yeah, so in terms of opportunities now for people to come in, if you're, let's say, a compiler expert, you can focus on just this one layer of the stack. If you're an assembly expert, you can, accelerate the really low-level cryptographic operations. If you're a tooling expert, you can help design the IDEs and make them user-friendly. If you're a security expert, for example, formal verification is a big one, right?
Yeah.
Proving that the circuit matches the program that your application has, and all of these things are very now modular and segregated from the rest, so you can just focus on what you're an expert on.
Do you think we are at a state where we could do a ZK hackathon this year? This is a wish of mine to have this happen, to be involved in putting something like this out there. But I feel up until now, it hasn't quite been ready. Is it ready for something like that?
when I think about the difference between where we were in, like in 2019, sorry, I'll just say real quick, like from 2019 when we did that thing in London to now, things have progressed a lot, but I don't think the user-facing tools have really, or like the people who aren't, like tools for people who aren't experts have really gotten to that point yet, because no one has really had a huge incentive to work on that. So, but maybe.
Maybe by the end of the year? That's my hope.
I'm sure DF would be happy to sponsor a session event.
To help something like that? All right, maybe we just try it anyway and we turn it into a recurring yearly thing. But thank you to both of you for coming and talking to me and to this audience about the state of zero-knowledge proofs. Thank you to the audience for joining, and enjoy the rest of the event.
Thank you.